In this topic, we'll look at the JDBC library for interacting with databases from Java programs. The Java Database Connectivity, JDBC library, is a suite of classes and their methods residing in the java.sql package, and for more advanced and recent JDBC features, in the javax.sql package. Now, this suite of classes includes a connection. Let me put that up here. Right there. And this represents a connection to a database server. And statement is another one, which represents a SQL statement. And also a result set, which represents the row and column results of a SQL query. Now, we'll go over these in more detail in a moment, of course. JDBC makes heavy use of SQL syntax in the form of strings passed to JDBC methods. So all we've learned about SQL will apply in the following discussion. Using JDBC requires a JDBC driver. Now, this is a set of classes that support the built-in JDBC implementation, and they provide details about connecting with and using a particular database server. A JDBC driver for MySQL is attached to this lecture. There are others for MySQL or for other DBMSs that you can obtain online. As you can see by the attachment, a JDBC driver generally comes as a single jar file with all needed classes within it. The mere presence of this jar file in your directory, or in your class path, is sufficient for the java.sql classes to find and use it. So you want to download the supplied MySQL JDBC driver and install it in your class path before proceeding. Adjusting your class path is presumed background for this lecture. Now, it's worth noting briefly that there are 4 different categories or types of JDBC driver, numbered 1 through 4. All types ultimately take Java method calls and translate them to network packets communicating with the database server. But the categories differ in how they do this. It's not critical to know what type of driver you have, but you should know that there are 4 types, and that the higher the number, the more powerful the driver. Type 1, in particular, may make certain database actions impossible. And the lower the number, the more general the driver. Each Type 4 driver is designed for one specific DBMS. You need a different Type 4 driver for each different DBMS. By contrast, a single Type 1 driver can work with a wide variety of DBMSs, as long as you can put up with somewhat limited functionality. The next major concept is that of the JDBC connection. Database servers, as discussed in an earlier topic, do not communicate directly with users, but rather with client programs, like the MySQL command client or MySQL Workbench. These client programs set up a network connection with the server at a given host machine, perhaps the local host, and at a given port, 3306 generally, and for a given database. The client sends commands across this network connection, generally in SQL form but more compressed than simple text, and it receives responses back, for instance, row and column data from a query, or an indication of the number of rows affected as the result of an update, or an error message for a bad query or update. Now, the server maintains state associated with each connection, including, for instance, memory cached disk blocks related to the database being operated upon by the connection, or a CPU thread devoted to receiving and executing queries or updates on the connection, and any open cursors, see below for more on that result from queries made by the connection. This means that setting up a database connection is a rather more substantial affair than just opening a network socket. The client generally opens up one connection and then uses that connection throughout the client session. Under JDBC, you use the JDBC driver to create a connection object representing a database connection. Here's a preview of some of the code we'll look at right there. And again, more on that in a minute. The connection object is from there on your go-to object for all things related to the database, especially for creating statement objects, see below for that, which in turn perform queries or updates. Now, another important concept here, briefly at least, is that of a connection pool. Sophisticated clients, like major web servers, need a separate database connection for each HTTP page hit or each web API call. Now, this could be done by opening a connection for each page hit or each call, but because connections are so costly to set up, Such sophisticated clients usually maintain a connection pool. By opening, say, several dozen connections, under JDBC that would be creating several dozen connection objects, and then maintaining them in a sort of free list or pool from which a page hit or API call may grab an already opened and ready connection object, and to which the page hit or API call returns the connection object once it's done with it for reuse by another page hit or web API call. Now, we won't set up connection pools in this class, but we still need to be aware of this sort of use of connection objects because it makes it clear why we must be in the habit of leaving a connection object in a proper state when we're done with it, for instance by doing various close calls that we'll get to shortly. Very often we're not the last users of a connection object, and we need to leave it in a good state for the next user. Now, once you have a connection, you can obtain from it statement objects to perform queries or updates. A statement object has a number of methods for performing a SQL command and getting results from it. And these methods generally take a literal SQL string that you assemble in Java using string operations before passing it to the method. We'll look at examples in the upcoming code sample. Now, we'll also look at an important subclass of statement called prepared statement that you configure with a SQL command having missing parts, for instance, a name to search for, or a GPA limit, and so forth. The prepared statement thus represents an almost complete SQL command, and you use it by filling in the missing parts and running the SQL, even repeatedly with different values filled in for the missing parts on each use, e.g. for different searches of a name or on different GPA limits and so forth. Prepared statements, as we'll see, are more secure and efficient. And then finally, in our general overview here, we have the JDBC result set. The outcome of a SQL query is represented by a result set. Database management systems often return the results of a query across the network connection one row at a time, requiring the client to make separate network requests for each row. The DBMS maintains an iterator, termed a cursor in DBMS jargon, for each query result, remembering which row it most recently returned to you and which one is the next to be returned. The client makes repeated network requests for the next row from the cursor, getting one row at a time in reply until all rows are returned. Now, we'll find that the result set reflects this cursor design. It's an iterator, which returns one query result row at a time. So, summarizing all of this overview, a typical JDBC program does the following things. It obtains a connection to the database server and the database, a database within it, possibly from a pool of pre-created connections. It then uses the connection to create a statement or prepared statement object. It then runs the statement or prepared statement, obtaining a count of rows affected for an update or a full result set for a query. It then traverses the result set, iterator style, to obtain each returned row, and it closes all the objects when done with them to release resources on the database management side and potentially prepare the connection for return to a pool and later reuse. Now that we have an overview, let's look at the JDBC pieces in a bit more detail. For instance, you needn't know all the details of the JDBC driver implementation, but neither should the driver jar file be a mysterious black box. And you'll want to know where to go in the API docs for the JDBC connection, statement, result set, etc. classes, and to have some familiarity with their methods. So here are a few in-lecture questions asking you to do a bit of research, most of which you'll need to do anyway in order to code to the JDBC standard. Question 1. Take a moment to dump the contents of the driver jar, and you can do that by including it in an IDE project configuration like that for Eclipse and expanding it, or just by running the command line app jar and -tf and the jar file name. What classes do you see in it that might correspond with some of the JDBC library classes we've just discussed? Coming back from a pause there, I'm bringing up my own Eclipse here. Here is the com MySQL JDBC. There's the jar file, and there's the packages within it, and here's com MySQL JDBC, one of them expanded. And you can see in here stuff like, there's connection class, and then further down it looks like we have at least a few things that have to do with maybe some statements, a prepared statement, and a statement class here. So this is not completely unfamiliar territory. Now, do note that these classes are not in the java.sql package. In fact, they're in com.mysql JDBC. And so they're not the library classes you'll actually declare and use. They're supporting implementations, which the java.sql classes hunt for in the class path, and then instantiate as private members of their own to get the heavy work of JDBC interaction done. The java.sql library classes are mostly coordinators of calls to the implementations provided by the JDBC driver classes. So, with that in mind then, question 2. Look up the java.sql.connection class in the Java API docs. And answer this question. Which of its methods do you use to create a statement? And how about a prepared statement? Must you know the SQL you want to execute when you create these? And the answer to that last question, by the way, actually differs between the two types of statement. So, coming back from a pause there, the place to look is the Java API docs and the java.sql package, as I kind of previewed earlier on, in fact. And we can look in answer to the specific question here at the connection class. And going down into that a little bit, what we find is that we have a create statement class that creates a statement object. And while it has some variations, it certainly doesn't require any SQL string. So looks like create statement is one of the answers. And if we go down a little farther, we'll find prepare statement. And this creates a prepared statement, again with some variations that give you alternatives, but in each case you're required to pass a SQL string. So when you create a statement, you don't need to know your SQL yet, but when you create a prepared statement, evidently you do, or at least a template SQL statement with missing pieces, as we mentioned above and as we'll go into more detail on in a little bit. Do note again that each of these comes in a variety of forms, allowing you to configure subtle aspects of the statement or prepared statement. Each of these functions has different overloaded forms. You don't need to know what all of those options are at this point, but be aware that they do have a lot of configuration options. Okay, so question 3. Let's go and look at statements API docs. And specifically within that area, what is the difference between execute query and execute update, both in terms of their SQL and their result or return value? Don't, by the way, worry about method execute. That method isn't used as often as the other two. Does it look like a single statement can execute just one SQL statement, or could it execute several different ones? Back from a pause, go and look at the statement docs. And if we scroll down here a bit, what we'll find is that there is a execute query, right? And that's used for a select statement. And it returns a result set produced by the select statement that was passed to it, of course. And by contrast, execute update is used for an insert or update or delete statement. And it returns an indication of the number of rows that were affected by the statement. And it looks like these may both be called as many times as you like, with different SQL each time, and that is the case. A statement object really doesn't represent just one SQL statement. It might have been better named statements executor, since you can do multiple statements with it. Okay, now do the same investigation for prepared statement. And in this case, answer what do almost all of its methods do, and which, if any, allow you to specify the SQL statement to be executed. Coming back from a pause, checking out prepared statement here. Now, this is a little different. Virtually all of its methods are devoted to setting or filling in missing pieces of the SQL statement that you supplied to connection.prepare statement when you created the prepared statement. And none of them let you revise the SQL that the statement itself represents. That's locked in. So a prepared statement represents one single SQL statement, which can be filled in various ways and re-executed with different filled-in values, but which cannot be replaced wholesale with a different SQL statement. Now in the next segment, we'll start a walkthrough of an example JDBC application that uses all these classes and methods and more.